Okay, good afternoon, everyone. I hope you're not too fast asleep after your big lunch. We're going to be giving you a quick introduction to the multi-cluster SIG, Kubernetes SIG Multicluster. The intention of the session today is really just to tell you who we are, what we do, what we think about, give you a little bit of background into some of the work that we've done in the recent past. And we have quite a fun demo for you today. Daneyon will be telling you a little bit about how they used Federation in particular, which is one of our sub-projects in the multi-cluster SIG, to deploy and manage Istio applications, both Istio and the applications that run on top of it. We'll have a healthy Q&A session afterwards, but I personally don't mind if anyone wants to interrupt me along the way. If you have questions that you would rather ask in the middle of the talk instead of at the end, that's also fine with me. Right, so we're going to talk a bit about our mission. We have these three sub-projects. One we call Federation. It's in version 2 at the moment. Another one called Cluster Registry, and another one called KubeMCI, Multi-Cluster Ingress. And then we'll have demos and Q&A, as I mentioned. So first of all, let's just step back from the specific projects and get an understanding of what the mission of the SIG is. So we started off, some of you may have been involved in the early history. It used to be called SIG Federation. We had this project to federate multiple clusters together. And then about a year or so after that, we broadened the scope of the SIG to multi-cluster issues in general. So there are many different reasons why people would want to run multiple clusters. We don't have time to go into those today, but for those of you who are interested, there'll be more discussion of that at the deep dive. Is it tomorrow? Yeah. But suffice to say, there are many different reasons you might want to run multiple clusters, and in particular, in some cases, large numbers of them, either tens, hundreds, even thousands we have cases of. And depending on why you're doing it, you might have different implementations that you prefer to use to manage these multiple clusters. And Federation turns out to be one of the more useful ones, but there are other ways of doing it as well. So all of those, we consider to be in scope. Anybody who's interested in running fairly significant numbers of clusters via whatever mechanism, we encourage them to interact with our SIG, cooperate where they can with other such efforts, or at least be aware of what other efforts are going on. So this is both the management of the actual clusters themselves, so the cluster configurations, things like quotas, RBAC, all the kinds of things that a cluster administrator might look after in clusters, as well as applications that run either in one of many clusters or in some cases across multiple clusters. So if you wanted to deploy an application that ran on every continent in the world, you wouldn't necessarily want to manage the application in every single one of those continents and make sure that the pieces in Europe could get hold of the pieces in North America if they needed to. We try and make some of that stuff go away for you. So we design, discuss, implement, and maintain APIs, tools, documentation, etc., related to both of those areas, cluster administration as well as application administration. These are not only automated approaches. So cluster federation, for those of you who might have come across it before, is a very active, it's a software managed system. So not unlike Kubernetes, you have declarative configuration that you say, I want n replicas across some number of clusters. And then there's software that has a reconciliation loop that makes sure that this is true from that point onwards. But there are other ways of doing it. You can, for example, check changes into GitHub, for example, and have clusters automatically polling GitHub to find out what their latest configuration is and not necessarily have an active control plane that looks after all of these clusters. We also consider that to be a valid approach, and there are groups that are following that approach as well. We have tried to not only build end-to-end solutions. So cluster federation to some extent is something that you can install and use as a complete system, but we also try to make it possible to use the individual building blocks involved there so that people who might have other use cases or different ways they want to implement multi-cluster management can at least make use of some of the pieces that we've built. So cluster registry is a good example. Most of these things need the concept of a list of clusters and how you get to them and what are the credentials that you need to communicate with those clusters, and that seems to be independent of whether you're using Federation, V1 or V2 or any other approach. And there are other examples of multi-cluster ingress is perhaps another example. In many cases, you need to build networks that span multiple clusters in one way or another. And that may be necessary irrespective of whether you use active federation control or some other mechanism. And there's lots more in our README file for those of you who might want to have a look at it. I think I've spoken mostly about the different sub-projects already, so we don't need to go into too much more detail there. Federation, I think, is interesting. So it went through a version 1 iteration where we basically prototyped the whole thing using the Kubernetes API. So we exactly used the Kubernetes API as it was defined. And wherever we needed to extend it for multi-cluster use cases, for example, specifying which clusters you want your application to run in and perhaps what proportion of your application runs in different clusters, we used annotations. And that was purely a sort of proof of concept mechanism to get an idea of whether we're solving a useful problem and what sort of other primitives might be necessary. Once we'd done that, and we got pretty far with that actually, we got the vast majority of the Kubernetes primitives were federated, so you could create federated services, jobs, daemon sets, services which could be discovered between clusters. All of these kinds of things were done. We never took it to GA. It was more of a proof of concept, and so we took the lessons learned over there and built Federation v2. That's got both simple propagation, so the ability to propagate essentially snapshots of the same Kubernetes entities to multiple clusters, but then it also has higher level functionality to do the management of these applications across clusters. So for example, make sure that if a single cluster goes down, your replicas get repopulated in a different cluster, and that applications in different clusters can find each other in a uniform way, irrespective of which clusters they might be running in. Cluster registry and multi-cluster ingress, I think I've spoken about enough for the moment. I think round about here, I was going to hand over to my good colleague Irfan, who's going to tell you a little more about Federation in version 2 in more detail. And then we're going to open up for a demo and Q&A. Do you want this?
Hello?
Hi. Sorry for that. Hi, folks. I'm Irfan. I work with Huawei, and I'm going to walk you through a couple of other slides, which basically talk about the current status of the projects that we are at, and a little bit of the roadmap, what we are going to do in near future. And after that, I'll hand over to Daneyon, who will show you a cool demo about federating an application like Istio. So I think Quinton already talked about the first sub-project in a little bit detail, which is Federation v2. So the concept of federation was to build a common API surface to multiple Kubernetes clusters, so that users who are willing to or trying to use multiple Kubernetes clusters, they should be able to easily do that, or make it easy for them to do that. As of now, the status of federation is that you can, or Federation v2 to be exact, is that you can federate, we use the term federate, any K8s type or any K8s resource, only using configuration, and you don't have to write code for that. And what we do is we define the federation APIs. We define the federation APIs as CRDs, like they are quite advanced now. And the generation part, or the federation, automatic federation part of that, we are using a tool, we call it kubefed2. And more details about this would be there in the deep dive that we would be doing day after tomorrow. So people or folks who are interested in that then can certainly attend that. Okay, so the community as of now is quite active. We have Cisco, CERN, Google, Huawei, IBM, Red Hat. All of these folks either are directly contributing, or a few of them are providing the use cases so that we can build on top of that. This is about Federation v2, what we have achieved in terms of features or in terms of exact use cases as of now. So we have sort of completed a version. I released 0.0.4 yesterday, and what we have completed is that we can deploy the Federation API as CRDs onto any active K8s cluster. We have a push reconciliation for any arbitrary K8s type. We have, in terms of higher level features, we have a cross-cluster pluggable DNS discovery, or we also call it a service discovery mechanism across multiple K8s clusters. We use another project for some portion of it. We call it external DNS. That project is also hosted in Kubernetes SIG. We have completed the config-based reconciliation. So we use federated type. We call it type config, which is something like mechanism which an admin can use to ensure what or which type to be propagated or which type not to be propagated. As I said, this is just a very high-level pointers to what features we have completed. We'll be talking much more about this in deeper details in the deep dive. I mentioned this earlier. We have a simple federation of any K8s type possible. And a highlighting pointer is that any CRD which is defined in a given K8s cluster can also be federated. So it's not only limited to first-class K8s resources. It's possible to do with any user-specified CRD also. We have a cross-cluster replica scheduler kind of a feature also, which can schedule replica workloads across the clusters. And we have a possibility of overrides. So the reconciliation is reconcile or propagate the same K8s resources which are desired into individual clusters. But while propagating, users can actually override particular fields in the resource so that it becomes a cluster-specific resource. In our roadmap, we are yet to complete status aggregation. So whatever resources are created in the clusters, currently, we do not have a direct view of or a user-centric view of the statuses of all those resources. So we are working on that. We are also working on some more high-level scheduling behaviors. One pain point right now, not pain point, one missing piece right now is that any given K8s resource, for example, you have a Helm chart, or you have YAMLs or manifest, which are defining your application in terms of K8s resources. There is no direct way of just translating that to federated resources. So we are working on that, where it can be automated. We use QFed for that. One more piece which is missing right now, and which is actually our next step, is the user-facing Federation API, where user can define in a very concise form or in a very small form what their applications look like or what their applications are supposed to be, which is more higher level or more easy for users rather than have to specify all the resources and all the spec of all the resources of their applications. One more thing which we might consider later as in terms of development is the pull reconciliation. A little bit of update on cluster registry. Like Quinton mentioned earlier, we have two other projects in this space as part of the SIG. So one is cluster registry, another one is kubemci. So cluster registry is almost there to be termed beta, except they have an outstanding issue which has to do with auth information to individual clusters. So there has been discussion going around that, and as soon as that issue is resolved, it would probably be released as beta. kubemci is a little bit mature. So last couple of months, the folks at Google were actually collecting feedback from users, their users of kubemci, and they have received a good amount of feedback, and a couple of users are actually using that in their environments. OK, with this, I hand over to Daneyon. He'll be talking about the federated Istio use case.
Thanks, Irfan. Can everyone hear me OK? Great. Let me go ahead and kick off the demo. It'll take a few minutes, and hopefully everything goes as planned while we give you a little background here. So why federate Istio? It's multi-cluster support. Similar to the progression of Kubernetes, Istio is now going beyond how do I run Istio in a single Kubernetes cluster to how do I run Istio across multiple Kubernetes clusters. Before getting involved in Federation v2 about 3 months ago, maybe 4 months ago, I looked at the landscape, and basically what I saw was the existing multi-cluster Istio solutions out there had caveats, workarounds. There was no really consensus on what's the best way to manage Istio across multiple Kubernetes clusters. And that brought me to Federation v2. And the reason, one of the first initial reasons why I was very interested in Federation v2 is that if we think of Istio is nothing but a collection of Kubernetes resources, right? And I want to be able to manage Istio, which is essentially an application, across multiple clusters. And I want to manage it the same way that I would manage any of my other multi-cluster applications, right? And this really gets into treating Istio as cattle, not as a pet. One of the features that I really like of Federation v2 is this multi-cluster cross-cluster service DNS, and DNS discovery, so that if you're familiar with Istio, service discovery is kind of a key component of the platform, and works essentially by leveraging a service registry within the cluster, which is typically done through DNS, either kubeDNS or core DNS. And Federation v2 has taken that same concept, but has now extended it out so that we can support that service discovery across multiple clusters. And Irfan touched on the external DNS project as part of that. And I feel like it's a simple user experience. Irfan mentioned that there's a higher level API that's being developed, or right now the community, we're still trying to figure out what's the best way of doing that. But from my standpoint, even the initial primitives of a template of an override or a placement resource is simple to understand. And when I look at my federated resources, they look very familiar to standard non-federated resources. So when I look at a federated deployment, it looks very similar to a standard deployment manifest that I would have for a single cluster. And I feel like Federation v2 has that balance of uniformity, so I can create a federated resource and know that it's the same resource that goes across my 100 clusters, but also giving me the balance that if a couple of those clusters is maybe a test dev cluster and I need to make a few tweaks and changes, that I have the ability with overrides to make those changes. And last but not least, as Irfan mentioned, it's a strong, diverse community, whereas when I was looking at other ways of approaching this multi-cluster Istio problem, I felt some of the projects that I saw out there was really no strong, diverse community behind it. And just one caveat too is when I was doing my research, it was really around at the 1.0 time, and I know that 1.1 within Istio, there are changes that are occurring that's making it better to run and manage Istio across multiple clusters. And so, what does federated Istio do? Right, we're able to manage the Istio control plane, so a pilot, citadel, so on and so forth, across multiple clusters. And it doesn't stop there, right? So now we're able to actually federate our microservices across the clusters. In the demo, what I'm going to be showing you is a book info application. If you're familiar with it, it's a polyglot application that has several different services, a review service, a rating service, so on and so forth. And then it exposes the application through a front end called product page. And I'm taking that same application and federating it using the placement template override resources provided by Federation v2. But the unique thing is, this is essentially the applications running across the multiple clusters and across the multiple Istio meshes. And think of it as kind of like cluster level replication. So if this was a production application, I'm not going to have a single instance of these application services running in a single cluster. And then last but not least is I can federate all of Istio's capabilities. Irfan mentioned that we can federate any Kubernetes resource type, including CRDs. So, right, I mean, if you're familiar with the details of Istio, you know that there's includes a ton of CRDs, right? So things like gateways and virtual services, service entries, all these extensions that Istio has implemented to make Istio what it is, right? We can federate those resources. And so I can now have these multiple Istio meshes across my multiple clusters and run a federated application like book info across these. But it doesn't stop there in the sense that I can now take the Istio capabilities like traffic routing, right, and have federated destination rules, federated gateways, and so forth. And I'm working on, I have an open issue to get federated Istio upstream into the Istio community. It's issue 2843. If it's something you're interested in, feel free to chime in and give it a thumbs up or say, let's get this upstream. Oh, and I also currently have it sitting in my repo. So this federated Istio repo just has docs, some deployment scripts and manifests so that you can follow the Federation v2 user guide and stand up a couple clusters and run your Federation v2 control plane, and then jump over to this repo and take the next step of running federated Istio. So let's see where the demo's at. Looks like we're still trying to get some connectivity. Let me walk you through what's happened here real briefly. Let's go back here. All right, so I run this federated Istio script from the repo that I just shared with you. One of the first things that we do, and let me take a pause here for a second, give you the background, right? So in this demo, I've got a couple GKE clusters in 2 different zones. Could be 2 different regions, whatever it might be, right? But I want you to try to imagine this actually being 50 or 100 clusters, right? And I have the Federation v2 control plane running in cluster 1. Cluster 1's also a target cluster, so whenever I create these federated resources, cluster 1 is not only hosting the Federation v2 control plane, but it will also propagate those target resources to cluster 1. And then cluster 2 is just a normal target cluster. But one of the first things I do is I federate these additional Kubernetes resource types. So when you stand up your Federation v2 control plane, as part of the deployment, the control plane creates some of these federated type configs, right, that tell Federation v2 these are the resources that I want you to handle for federation. And there's certain native Kubernetes resource types that the standard installation doesn't include. So I add some of those here. Let's see, I create the Istio namespace. And so if you're familiar with deploying Istio, you're going to see that this is a similar look and feel to your normal deployment. And what I did, a little background, is I took the standard Istio YAML deployment that includes all those, deployment for Citadel and Pilot and the service accounts and the secrets and the mutating webhook configuration, blah, blah, blah. And I federated all that. It was a little painful, as Irfan mentioned. There's work that's happening to go ahead and simplify that process. But back to the demo here is I create the Istio namespace, installing Federated Istio. And again, like I said, if you're familiar with installing an Istio control plane, you'll see that these are the config maps, the service accounts. But you're going to notice one big difference is you see the Federated config map and the Federated config map placement, right? And so that Federated config map, that's a federated representation of that Kubernetes resource type, and then its associated placement says where do you want to actually, which target resources or target clusters do you want to instantiate these resources. And so if we keep going, and again, if you're familiar with installing Istio, you'll know that there is a ton of resources that are involved here, right? So it's finish installing Federated Istio. I do have an open issue where, and this is actually an upstream Kubernetes issue when we actually try to, or when we federate mutating webhook configurations. There's a bit of an issue, but again, it's known upstream and it's being resolved. So hopefully in the near future, I'm not going to have this workaround and be able to actually federate the mutating webhook configurations. Let's see, federating the Istio custom resource types, right? So as part of the Istio installation is it creates a bunch of CRDs. Okay, and after Istio is done installing and create those CRDs, we now federate them so that we can manage those federated resources like any other native Kubernetes federated resource. Let's see here. And then I create these federated Istio custom resource types. So federated attribute manifest, federated metrics, federated rules, so on and so forth. Let's see here. Label the federate the Istio control plane installations deploying the sample book info application, right? So now, I mentioned kind of the 3 bullets of federated Istio with managing the Istio infrastructure across multiple clusters, but we can now use federation to federate an application. That's what we're using book info for, so that we can create the book info application across the clusters, have them run on the Istio meshes. And since we're able to federate these custom resources like a gateway and a virtual service, we then go ahead and do that so that we can expose the book info front-end product page through the gateway resource and implement the federated route rules or destination rules and virtual services and so forth. One of the things we do here is I also create the external DNS controller. So I mentioned that Federation v2 has this ability to support this multi-cluster DNS. And one of the ways that it does it is integration through this external DNS controller, right? So when you create either an ingress or a service DNS record through Federation v2, the ingress or the service DNS controller as part of Fed v2 will create something called a DNS endpoint. That DNS endpoint, that's exactly what this DNS controller is looking for. And really all that is just a bunch of DNS record information. And let's see here. Let's see here. I got a 200 code here. So I just wanted to make sure that didn't have any demo problems. But last but not least, we create the federated domain that helps kind of stitch the different clusters together from a DNS standpoint. And then I just go and test and say, okay, is this federated application available outside of these multiple clusters? And I did that by just curling it. And so we've got the application here. Let's go ahead and just go to a browser so we can see what it looks like. network now. Curl-i.
At the bottom of the terminal.
You gotta be kidding me. Oh, did it? Oh yeah, it did. Let's see here. I am. Yeah, and this has worked well for me, but I was mentioning before that the DNS propagation for whatever on this network is taking a long time. So maybe we could just open up for questions and come back and see if this shows up.
Maybe we could watch it and then turn the Wi-Fi. Time it has a lease on. Then we'll know. You put a watch on the code.
Yeah.
With a question over here.
So if I understand what you're doing here, you are basically deploying several Istio instances, right? So several meshes. I think the objective of Istio Multicluster was to have one mesh spanning across multiple clusters. So it's a different use case. So can you explain why, or what use cases you're seeing?
Yeah. I can that. So what Daneyon was trying to show here is that Istio is a complex application. It's a huge application, and it is quite easy, or it was quite easy to federate that, which has tons of resources, and it can be done. So it's not necessarily offering a solution for multi-cluster using Istio. I mean, that might be a confusion I thought the viewers might get. It is just to showcase that it is easy to federate a complex application like Istio also. And just like Istio, he did federate the book info application also, which did span multiple clusters. So
yeah, and just to add to that too is I've done more in-depth discussions on this effort, but I was a little short on time today. But even though in this implementation we're deploying an Istio mesh in each cluster, the Federation v2 primitives are there where you can go ahead and say, okay, I want certain control plane components in cluster 1, certain control plane components in cluster 2, and so on and so forth. But my use case was that I want separate Istio meshes in each cluster. And I can leverage the external DNS to do the service discovery so that if you go to the repo that I shared with you, you'll see examples for cross-mesh policies, right? And so in this instance, we've got a federated application. We're exposing it out to the world, but in some of the other examples I have with the cross-cluster service policies is being able to make sure that we can leverage Istio rules and policies to allow services to communicate across the Istio meshes and the clusters. You got to be kidding me.
you can pass on.
I have lots of questions, but I'll pass on for my first one. You talked a bit about kind of cluster registry and setting that up. My initial thought was, what's the story around like high availability? Like if I have my cluster that has a cluster registry on it and it goes down, can I then not deploy, or what's the story there?
So if I understand your question, you're talking about the high availability of cluster registry?
Yeah, or like I want to be able to federate, I have my CI/CD system set up so that I can deploy to my federated system. And so I guess I'm probably going to need multiple cluster registries so that I can do high availability.
Yes. So there's a possibility of leader election feature which might be integrated with cluster registry, but it's not there.
Okay.
So currently it limits itself to one cluster only.
I just want to add one thing there, which is the cluster registry is essentially two things. It's an API definition. So if you're writing applications, you know what the API looks like. And if there is a cluster registry available to you, you know exactly what it looks like. And then there's a reference implementation of it, which currently I don't think has much complex HA stuff, but it's reasonably easy to build. And other people will build cluster registries with the same API, which is HA.
So my question is around storage classes and stateful applications and how it works with Federated v2. If I wanted to, say, create a key value store that has part of my data in one cluster and part of my data in another cluster, and make that ubiquitous between the two clusters, will I still be able to access through this format the actual data that I need?
Yeah, so what we have so far built is replication of all KTS resources, so sort of propagating the same KTS resources with some updates or changes in different clusters. What you're talking about is possibility of having a storage class or having a stateful application where the application could span across multiple clusters. So the possibility is to build that kind of application using these primitives that we have built in Federation right now. And the next step is that, actually, to build higher level behaviors or higher level applications using these primitives.
Hey, Irfan, really quick too, it was actually my fault here. I thought it was KubeCon, but it was KubeCon 1 was the correct DNS name. And so you see that, that I've exposed the product page front ends, right? These are actually to the product pages in each of the clusters, and I'm using GCloud DNS as my DNS provider. And you can see here, I've just done a lookup on the zone to get the DNS information, and you see the mapping of the different A records and a CNAME record as a vanity URL that's being created. And you see that I'm hitting the book info application, basically the product page front end, even though this network really stinks. Okay, there we go. Now, one last thing that I want to mention is we can federate the Istio resources, so the gateways, the route rules, all that good stuff. And I've done that, right? And so if we go ahead and if you've seen this demo before, you see that what I was showing you with the product page front end is sometimes you see red stars here, black stars here, or you just see no stars. Those are the different versions of the review service. And so I've federated the virtual services and the destination rules to say, hey, point everything to reviews v1 so that you don't get any of the red or black stars. And again, this, if you've seen this demo before, you're like, okay, what's so special about it? Well, it's the same look and feel, same resources we're using, it's just federation. And so we're doing this across multiple clusters for this application. And every time I refresh, I'm not getting any of the reviews v2 or v3. Yep, thank you.